Hello and welcome back. In section 2.6, we get to work with quadratic equations in one variable. So we're going to start this section with a little hypothetical. So let's say that I tell you that I am thinking of some number. So I don't tell you what my number is. I just tell you I'm thinking of some number, it's on my mind, and I tell you that I think of a second number, and the third thing I tell you is that the product of the numbers is 12. You would not want to bet very heavily that you would be able to come up with the two numbers that are on my mind. Sure, it could be 1 and 12. It could be -1 and -12. Could be pi and 12 divided by pi. Similarly, it could be e and 12 over e. It could be 24 and 1/2. And there's an infinite number of possibilities. But if I change one small part of our experiment and I tell you that the product of the numbers is 0 instead, now you can tell me something for sure, written in stone. You know definitely one number must be 0. We don't know for sure what the other number is. There's an infinite number of possibilities for that. But we know for sure if I tell you I'm multiplying two things together and 0 is my answer, one of those things has to be worth 0. So in other words, if a times b equals 0, one of two things is true. Either a equals 0 or b equals 0. That's our 0 product property. So what does that have to do with quadratic equations? Well, really, that kind of encompasses our goal for solving quadratic equations. We really want to check for two things. Is one side equal to 0? If no, fix that. And your next question, is the other side factored? If it's no, fix that. Once you fix that, set each factor to 0 and solve the resulting equations. Now we're still in chapter 2, so again, recall that our domain is I unless otherwise stated in this chapter. All right, so we'll start with a short one. We'll do an x squared plus 15x minus 16 is equal to 0. So my three questions, or my two questions, and then really just a procedure after that. Is one side equal to 0? Yes. Then we can move on. Is the other side factored? No. Then that's where we get to practice our 2-5 work. So here A is worth 1, B is worth 15, C is worth negative 16. So A times C is negative 16. So we want a product of negative 16. We want a sum of positive 15. Product is negative. We have one of each sign. Sum is positive. So big absolute value gets positive. Little guy gets the negative. And right off the bat, we get a -1, positive 16. Now, since our leading coefficient is 1, we can do the fast factoring on this of just putting an x at the front of each factor and bringing our coefficients over, our terms over. So a -1 and a plus 16. It has to stay an equation. Don't forget this step. It does still have to stay an equation. We can't temporarily just turn it into an expression and then later on turn it back into an equation. If it starts an equation, it stays an equation. So is one side 0? Yes. Is the other side factored? Yes. Then we just go through our procedure. Set each factor equal to 0 and solve. So either x minus 1 equals 0, and we'll union that up with x plus 16 equaling 0. You can either write the word or you can use the union symbol. We can't use the word and here. That would give us an empty set if we used an and or is what we need here. We need the union. So then we're just adding 1 to both sides. So x plus 0 is 1, so x equals 1. And the other one will subtract 16 on both sides. So x plus 0 is negative 16, so x is negative 16. Those are both in set of integers, so they will both go in my solution set. So both of those will give true statements if we plug them in to the original. So 1 squared is 1, 1 plus 15 is 15, 1 and 15 is 16, 16 minus 16 is indeed 0. Negative 16 quantity squared, 256. 15 by negative 16 is negative 240, and subtract another 16, and we're at negative 256 again. So both of these give us true statements in the original. Okay, so next up we're going to solve, and x squared minus 7x plus 12 is worth 0. So one side is already set to 0. Then we want to know, is the other side factored? Right now, no, so we fix that. So a is 1, b is negative 7, c is positive 12, so we want a product of a times c, 1 by 12 is 12, and we're looking for a sum of negative 7. Now, we're multiplying to a positive, so it's either plus plus or minus minus. The fact that we are adding to a negative tells us everybody gets a negative. So negative 1, negative 12, right product, wrong sum. Negative 2, negative 6, right product, wrong sum. Negative 3, negative 4, however, has both properties that we need. Leading coefficient of 1 means we can do the fast factoring on that. So x minus 3 times x minus 4 is equal to 0. Then we set up our two equations now that the other side is factored. So x minus 3 could be our 0, union that up with the possibility that x minus 4 is our 0. So x minus 3 plus 3 is 0 plus 3. So x plus 0 is 3. X equals 3 is one possibility, and we'll union that up with our other possibility. So x minus 4 plus 4 equals 0 plus 4. So addition property of equality. Additive inverse gets us to the x plus 0. Additive identity gets us the 4. Additive identity one more time, and x equals 4. Those are both in the set of integers, so they both belong to our solution set. So we get to keep both. Let's do section here. So we'll try a 7x squared plus 54 times x minus 16 is equal to 0. So one side is already set to 0. The other side is not factored, so we fix that. So A is 7, B is 54, C is not just 16 but negative 16. So 7 by negative 16. And we're looking at a negative 112 for a product. So negative one of each sign. Sum is positive, so big absolute value is positive, little absolute value is negative. So negative 1, 112. Right product, wrong sum. Negative 2. And that would be negative 56. Negative 2, positive 56, and we have our winner already. Since our leading coefficient is not 1, we don't get to do the fast factoring. So I'll hang on to the 7x squared, but where I used to have the plus 54x, now I have a minus 2x and a plus 56x. We still have our minus 16, we still have our equals 0. Then we pull common factors. I can pull a common factor of x from the first two terms, leaving me a 7x minus 2. I can pull a positive 8 from the second two terms, leaving me a 7x minus 2 again. And we're still equal to 0. A couple notes on here. Don't forget the sign in between, even if it's just a plus sign. Without it, you're telling me that you're multiplying all 4 of those together. After that, if you've done the factoring correctly, you should see the same thing appear in both. So pull the 7x minus 2 and keep our x plus, I have an extra plus sign there. Let's write that a little nicer. Common factor 7x minus 2. We'll hang on to the x plus 8, and we're equal to 0. So then we'll set each one to 0 and solve. So the first one, addition property of equality. Additive inverse gets us to 7x plus 0 on the left. Additive identity gets us to 2 on the right. Additive identity again, 7x equals 2. Multiply by a 7th. So 1x is 2 sevenths, so x is 2 sevenths. And we'll union that up with our other solution. X plus 0 is negative 8, so x equals negative 8. In this case, 1 is in the set of integers, 1 is not in the set of integers. We've seen that before, so we just figure out what, if any, goes into our solution set, and then we go to our Euler diagram. So there's our set of reals, split between the irrationals and the rationals. Within the rationals, the integers. Within the integers, the whole numbers. Within the whole numbers, the natural numbers. Our domain that we will lightly shade is a set of integers. We got to keep the negative 8. We do not get to keep the 2 sevenths, but it is real and rational. Okay, so now I'm going to have you try one out. So once I put up the problem, go ahead and pause it, run through the problem, and see what you come up with. We've got 6x squared plus 19x minus 20 is equal to 0. So go ahead and pause it. Solve that problem. Okay. So we were already set to 0. So we can identify our A, B, and C. So A is 6, B is 19, and C is negative 20. So our product, A times C, 6 times negative 20, negative 120. So we're multiplying to a negative, adding to a positive. Big absolute value gets positive, little guy gets the negative. And this guy has lots and lots of factors. So we're already getting closer. We had a sum of 111 when we started. We're already down to a sum of 26. And let's see, if I will go into the 12 twice, 2 left over, 5 into 20 would be 4 times, and there's our winner. So even though we could keep going, once you find it, and don't go in random order, just increase each time when you're checking these. Be systematic so you don't miss anything. So I'm going to hang on to that 6x squared, but instead of a plus 19x, I have a minus 5x, followed by a plus 24x. And we still have our minus 20 there, and we're equal to 0. So then we're doing our factoring by grouping. The first two terms I can pull an x, leaving me a 6x minus 5. Second two terms, we can pull a positive 4. You do need that plus sign in between, leaving me also a 6x and a minus 5, and we're still equal to 0. Another often forgotten piece of the puzzle. If it starts an equation, it stays an equation. Then we'll pull our GCF. So 6x minus 5 by x plus 4 is equal to 0. And then we set one factor at a time equal to 0, union in the middle. So our first one, I'll just add 5 to both sides of the equation. So 6x plus 0 is worth 5. So 6x is worth 5. Multiply both sides by a 6. So 1x is worth, that is a 1/6 there. 1x is worth 5/6, so x is 5/6 is one possibility. So we see an Euler diagram in our future. So x plus 0 is negative 4, so x equals negative 4 is our other solution. So the one that we get to keep the negative 4, and then we get to draw an Euler diagram. So the reals split between the irrationals and the rationals. Within the rationals, the integers. Within the integers, the whole numbers. Within the whole numbers, the natural numbers. So our domain, since they didn't specify otherwise, is set of naturals. So remember, that does include the whole and natural numbers. Those are part of the set of integers. So the negative 4 is an integer but not a whole number or a natural number. 5/6 is real and rational but not an integer. All right, so far every time the answer to do we have one side set to 0 has been yes. That's not always going to be the case. Sometimes we might have something like 5x squared minus 13x is worth 2x. So is one side equal to 0? Yeah, at the moment, big fat no, so fix that. So I'm going to subtract 2x on both sides. The reason I picked the 2x rather than moving anything else, generally these problems are going to be easier if a is a positive, and here a was already a positive. So we have 5x squared minus 15x is worth 0. So then we're looking to factor the other side. So here, our a is 5, our b is negative 15. but our c is 0. So here we can do factoring by GCF. So I can pull a common factor of 5x, leaving me an x minus 3. We're still equal to 0. So I still have two factors to set equal to 0. Either my 5x could be 0 or my x minus 3 could be 0. So just because it didn't have two terms doesn't mean it's not a factor. 5x is still a factor in this problem. So we'll multiply both sides by a fifth. So 1x is worth 0, so x is 0 is one possibility. The other possibility, x could be our positive 3 here. X plus 0 equals 3, x equals 3. So there are two values that give us true statements. We'll keep them both, since they were both in the set of integers. Alright, so let's try, maybe I'll try one more. This is sort of a good culmination problem. So go ahead and pause it, solve that, and unpause it, see if your solution checks out. Okay, welcome back. So we didn't have one side set to 0. In fact, this is the exact number that I mentioned earlier in our little analogy of, do you want to wager on your risk that you're guessing my numbers? Too many possibilities to multiply to 12. So we're not factoring this yet. We're setting one side to 0 before we do anything else at all. So I'll just subtract 0 or subtract 12 on both sides in order to set one side to 0. That's just our addition property of equality at work. So that property not only holds up for the linear equations that we saw before, that is still useful in quadratics as well. So the other side is not yet factored. A is 5, B was 28, and C was negative 12. So we're looking to have a product of negative 60, so 5 by negative 12. So one of each sign. The fact that our sum is positive tells me the big guys get the positive, little absolute values get the negative. So negative 1 and 60, no dice there, negative 2 and 30, and there's our winner already. So hang on to the 5x squared. Because of this a not being worth 1, we do the factoring by grouping instead of the fast factoring. So a minus 2x and a plus 30x. Minus 12 is equal to 0. First two terms, I can pull a common factor of x, leaving me a 5x minus 2. Second two, we can factor a positive 6. So you might have noticed, okay, I could have pulled the 3 there. Pull as much as you can. So yeah, they're both even. We could have pulled the 2. Pull as much as you possibly can. Pull that GCF, greatest common factor. So 6 by 5x is 30x. 6 by negative 2 is negative 12. And we're still equal to 0. If you don't have your equal 0, write it in red if you need to. Highlight it if you need to. Do something so that you remember it. Common factor here, 5x minus 2. First term I'm left with an x, second term I'm left with a plus 6. So that's just our distributive property at work again. So then we set h to 0 and solve. So the first one, I'll add 2 to both sides. So 5x plus 0 is worth 2. 5x is 2. Multiply both sides by a fifth. So 1x is 2/5, x equals 2/5. So Euler diagram in our future. Second one, subtract 6 on both sides. X plus 0 is -6. X equals -6. That one we're happy. We get to keep that. So that'll go in our solution set. The other one, since we did have one outside of our domain, up goes the Euler diagram. So -6 is inside of our domain, and the +2/5 is outside of our domain. All right, so you should be able to try the 2-6 exercises. Those are at the end of chapter 2. And if you have any questions, please feel free to get in touch and stay safe out there.